Hi, welcome to another episode of Test Gear Tuesday. Today we're going to look at my Pride TF-1000. This is a frequency counter and a clock. This frequency counter has a small cult following. There's only a few videos here on YouTube about it, not too in-depth. So hopefully today I could rectify that in my video. We'll get a little deeper into the guts and the movement of what makes this work. Some of you are familiar with Matt over there at 50s Transistor Radio. He and I correspond via email, and sometimes he'll send me clocks or other widgets that he has, and that's going to make future videos. And one of them was, well, he has one of these right here, because as you know, he's into clock. So here recently we've actually been discussing it a little bit more. And so make sure you look for his video on the same topic. And if you're not familiar with Matt, I will leave a link to his YouTube channel down below, so make sure you click on that. Go over there, subscribe, and tell him Jack had sent you. He would appreciate that, and for the first 500 subscribers he'll give you a free vintage radio. The only qualification for that is, well, good luck collecting. Of course, you know, I just made that up, just joking, it's not for real. So I started working on this, and I thought, well, maybe I should go ahead and do a video, and that's where I am now. I have it halfway taken apart. Started out, I was just poking around and looking around, and I decided to just go ahead and service it while I'm here, for the primary reason tearing this case apart, at least on my example, was extremely challenging. This plastic shell, and each half slides down into a slot, and it probably hasn't been open for quite some time, because when I did that, you could start hearing the plastic starting to break. It was really challenging to tear apart. And it's got these dividers in here, and so what I'm going to do when I put this back together is I'm going to break it like I just did. Well, we heard something break and fall. I don't know what that was. But what I'm going to do to rectify that for future servicing is keep bumping the camera. So I'm going to lubricate this. I'm not sure if I'm going to put oil or grease in there, and I'll make that easier for future repair. I think right here, see that line? I think that's where it cracked. So I might hit that with a spot of glue. In fact, well, that might be a seam. See the line going from there to there. So that might be seam, but that one definitely is hard. So in case you have one of these and you're going to open it up, take heed, be very cautious, be very careful. Very brittle. Frequency counter comes from, it was made in 1977. There's not a lot of information on the internet in regards to the frequency counter as well as the manufacturing company, which was Pride Electronics out of San Diego, California. And you can see that with my example, I do have the service manual for it, owner's manual. This is free, available on the internet, cover to cover. Everything you need, theory of operation, parts list, and it also has service manual schematic on the rear. Just do a search for it and you will find it free of charge. No need to go to eBay or other and buy it when it's free. What information I was able to find in regards to the company Pride Electronics out of San Diego, California. I say San Diego, California because, well, that's where they're from, and there are several different Pride Electronics, so just take heed that you're looking at the right one. The company, what little bit of information I was able to gather on the company, took out about a $900,000 loan in 1977 to help finance the company. Almost immediately, they ran into some issues with the bank, and the bank wanted their money back, and it ended in a 10-year legal battle with the owners of the company and the banks to get that rectified. And way how I read the what was it, the 140-page deposition, it looked like Pride Electronics came out the victor on that. Judge overturned some things. So the company is no longer in production. I don't know exactly when they went out of production, but I get the sense that it was about 1976 when it started, 1977 probably when they went into more of a bigger production. Not sure how big their product catalog is, what all they made. I do know for sure this frequency counter and a CB RF amplifier. Not a lot of information I was able to garner on their product catalog or company. If you know anything more to add to this, go ahead and leave it down below so others can will have that information, learn from it as well. The specs on this frequency counter is 1.8 megahertz to 40 megahertz, and it offers sports a 12 and 24 hour clock. Right now we have it in the 12-hour position. Now this frequency counter is designed for CB operations or ham HF operations. Let me pick this up. I do have it plugged into power. There's no on-off switch to it, and I've got lead wires coming out of the bottom. Here we'll look at the back, and here you can see we do have a fuse, mains cable, serial number. Not sure how long production run, but from what I'm seeing, it's probably either low production, so it's very plausible I have a really early one. We have a switch here for 25 watts or 250 watts, and our setting of our clock, and our 1224 position here, and then our input and output of our RF. Actually, it's the other way around. Back here on the front, you see we have the nice red LED display, really nice, nicely spaced out. I really like this clock, and I can't wait to one day put it on my bench to use it A as a clock and B as the frequency counter. Really nice large text down here, definitely cannot miss it. And then we have a switch here to go from auto to clock, and when you have it in auto mode, when you push the PTT on your transmitter, the frequency then will jump up and display as such. And then when you release the PTT, it goes right back to clock. I do not have a transceiver or a transmitter in here, so I have to jerry rig it here a little bit. We also have a red LED here on the display. I'm not sure what this is. The manual does not declare what it is, and changing the clock from AM to PM does not seem to make any difference what that does. One thing I haven't tried was pushing the 24 button, 12 and 24, and that didn't make any difference. But I can see now that I've actually got it set for 2 a.m. as opposed to 2 p.m. As you see, there is no discerning numbers denotation for AM or PM. We have 3 buttons on the rear. One is fast, slow, and hold for the clock. This is the current time for the clock. Let's go ahead and try setting this clock, and we'll push, I believe this is going to be the fast button. Nope, that's the hold button. And when we hold it, it does just that. We'll come back to that in just a moment, because when you see the fast, you'll understand. That's fast. Nope, I lied. That's slow because we're in the second time position. Now we'll go to fast. There is no backwards, only forwards. So if you overshoot your time, that's where the hold button comes in. You could hold the clock until it is on time, and you could release it, and there you go. Well, it's kind of interesting. It is not looping over to looping back over to 0-100 or 0-100. Speed that up a little bit. Interesting. So now I'm wondering if there's not something wrong there. You saw that it hit 100 hours just briefly and then goes right back to 2000. So it's very well plausible that that could be a AM/PM denotation if my clock here has a issue. Okay, so 0-100 there. We'll have to clean the switch. Maybe I have a dirty switch. But either way, that did not. Let's try to bring it to PM. Okay, that's close enough to the time there. So let's go ahead and switch it back to 24 hours. Okay, I'm going to have to check that out. Could be dirty switches, but rather interesting. Anyway, let's move forward. Back over to the frequency counter spectrum. Since I don't have a heavy RF amplifier in here to excite it through the SO239 connections, I went ahead and bypassed the network here, these two resistors that you can't see. So since I couldn't run through the SO239 connectors and then go through this network, which is these two resistors here that cut down the RF power, I just bypassed it, and the red wire here feeds up to this tan wire, which goes into the resistor. So I just bypassed it there, and then the ground goes to this ground terminal, which you can see goes right here to this chassis mount. And so that's all I did, and I found that it requires, depending on where you're at in the spectrum, anywhere between 1.4 and 1.6 volts to excite the frequency counter. While we're here, let's go ahead and look at the rest of the inside. And so here we have a nice, lovely wide shot. And as far as wide shots are concerned, I would have to say that that is a fantastic wide shot. Could you get any better than that? It's not tight, but it is wide. This chip right here is a MM5314N, and this IC is responsible for the clock portion of this device. And this ICM7208 here in the middle of your screen, this is responsible for the frequency counter portion of this device. And this 74SO4 that you see in between the red and the black lead there, this is a input chip. Purpose of this is twofold. One, to provide a squared input signal for the next chip, and the other is to provide a buffer driver signal for the automatic switching circuit. And this 74S196 is used to divide by 10 before the input of the 7208 IC. So the 7208 can be ran at a faster sampling rate, thus increasing the speed of display updating. And lastly but not leastly, these three 4016s, they consist simply of 4 SPST switches with control gates brought out to separate pins. Pin 14 is tied to the supply voltage of plus 12 volts. Pin 7 is connected to the supply ground. The inputs of the switches are on pins 1, 4, 8, and 11, and the outputs are on pins 2, 3, 9, and 10. The control gates are on the pins 5, 6, 12, and 13. The gates must be high for the switches to be on. So that almost makes me sound like I know what I'm talking about. But in reality, all I was doing was reading from the theory of operations. But hey, don't tell anybody. So, this frequency counter, as you can see, is all stock. I do plan on replacing the 3 electrolytics. And I will adjust the frequency of the crystal. The crystal in question is not a standard 10 megahertz. In reality, it's actually a 6.55 something or another megahertz crystal. And then the time base on this is a 1 megahertz, not a 10 megahertz. And I know that's very true for a lot of your vintage frequency counters. A lot in my collection, that's exactly how they work, is off of a 1 megahertz time base. And I think it was just the technology back then of the components used. I know that we didn't have a standard as of yet back then, so you might also have some that use a different time base than that. As far as the timekeeping piece on the frequency counter, there is no time base for it. it gets its frequency from mains voltage. So as long as you have 60 hertz running into this, it should stay pretty steady. Now, as stated, the specs on this says that it's good from 1.8 megahertz all the way to 40 megahertz. Not sure exactly what the minimum RF is required. However, most CBs are 4 watts, so I would imagine it probably 2 watts at a minimum to excite it. It has a accuracy of plus or minus 0.003%, and I actually have my generator at 10 megahertz, so you can see that we are definitely within our range there. Now, full declaration, this frequency counter as well as all my generators have been on at this point about 5 hours in this open air state. Frequency fluctuation really hasn't, not by much, maybe 1 microhertz there, but that was about it. Nothing too major. But as stated earlier, this has no on-off switch, so it's intended to be powered on 24/7, and it should be stable at any point in time of usage. So let's go ahead and test this to see really what it can do. In my findings, as stated, 1.4 to 1.6 volts, depending on the spectrum. I'm going to leave it right now on 1.5 volts, and that's peak-to-peak volts that I'm using, and we will test this out. I'm also going to leave this generator in sine wave mode, and let's go ahead and hit the 1.8 megahertz. Looks pretty good. Now on this generator, I cannot do anything above 21.5. So let's play with the low end, and then we'll jump to the high end. So we are fat and happy right there. Now, what I've actually found in my testing, I won't go in and bore you to tears. What I actually found is this frequency counter, only by its limitations of the display, will drop down to 100 hertz, which is what you're seeing right there. That's 100 hertz. And I would suspect that if you had more ability, this thing would probably read a little lower. Now, the pulsating that you're seeing on screen right now is not the display. That's actually the camera. And in a future video, I will get into why that is. So let's go ahead, since we see that it drops down just fine to 100 hertz. There's 400 hertz and 1000 hertz. And then, as stated, the highest I could go on this frequency on this generator is 21.5. And so we see that right here. Again, this is in sine wave. If I was to go over to RF, that's not a problem. This will also work in sideband, providing you have a tone or something to excite it. So let me go ahead and switch this into sideband. And there we are. This is, as you see, 1 meg, 1.4 volts, lower sideband with a 1000 kilohertz tone going into it. Definitely workable. Let me go ahead and switch generators. I'm going to drop down to the HP 8660. The other one was the BK Precision. And let's go ahead and turn the RF up on this. Did a wide shot so you can see me punching numbers in here. You really can't see the display too well, but you can make it out. Squint, you'll see it. Put your old-timey glasses on. So there we have a 1 meg signal. If I drop this down to 100 kilohertz, takes this out of range, but you see that it does it. You want to see a CB frequency if you were to use a CB frequency? Okay. So let's go to 27.085 megahertz. That's channel 11 on your CB. And that's what you'd be presented with. Channel 1 is 26.965 megahertz. And channel 40 is 27.405 make it hertz. Let's go ahead and go up to the high end of the spectrum that it says. It said it was good for 40 megahertz. And there you go. Now I believe the limits that I found, and I think it's only a limitation of my device here, because I didn't have enough RF to put into the device, or it could have been my feed line, which is just that, nothing spectacular. I think I was 53.5 megahertz. Let's go to 53.55 megahertz. 54 megahertz. 55 megahertz. 54.55 megahertz. 54.6 megahertz. And this time the flashing you're seeing is on the display of the frequency counter. And again, I think if I had more RF to pump into it, it would probably read. I mean, because you see there. And so what's happening now is it's automatically going into its clock circuit. So if I was to unplug this, we will see that happen. So you release your PTT, and then you mash your PTT. There you go. Oh, look at there. And I don't have any more moose juice to give it. That's it. So very comfortable at, what was it, 54.5 megahertz. Okay, maybe not so comfortable, but it does work. Again, that is pulsating in real time. 54.3. So in my environment, at the 1 volt peak to peak that I have pushed in there, that's working out just fine. So the device definitely exceeds its specifications. I had thought about putting a BNC on the back and a toggle switch so I could use it just as a frequency counter as opposed to having it in line for a transceiver, but I figured, well, since these things have a cult following and they are worth a little bit of money, I should probably just leave it as stock as possible. So that's what I'm going to do. It's not like I don't have any other frequency counters. One thing also to note of this, two things to note. It does have a little porthole on the bottom that you could feed through to adjust your frequency counter. And let's take a peek at this again. So here's your frequency counter slug adjustment. There is no battery option in here to save your clock setting. So if you lose power, you'll have to reset your clock. So what I'm going to do now is I'm going to go ahead and conclude this video. The rest I'll just do off camera. I'm going to go through the device. I'm going to replace those capacitors. I'm going to clean the switch and all the connectors. One thing I forgot to show you real quick was inside here. You see the front pops loose from the main board, and then these cables right up in here, they just pull out, so it's really easy to pop that out and service it. And I'll go ahead and service it off camera, clean it up, replace the components, do some electronic contact cleaner on what I can, and take it from there. As far as the clock is concerned, at this point in time, I don't know how hardcore I'm going to get into trying to hunt down that problem if just these basic things don't fix it. I have a lot of things, a lot of projects on my plate right now, so it's not a high priority that clock functions adequately and properly at this point in time. Well, thanks for watching, and as always, I do appreciate it. And to all my new subscribers, thank you very much. I definitely do appreciate your support, and you like my channel enough to follow along. Stay tuned. I have a lot of junk, a lot of test gear, a lot of radios, electronics as such, and they'll be coming your way just as soon as I could work on them. Also look forward to Matt's video and go check out his channel. Okay, thank you very much for watching, and we will catch you in the next Test Gear Tuesday.